Hi, it's Sue. We're going to do a couple problems about area. This is from the handout of area and volume AP problems, so you need to make sure you've got that. They're organized chronologically, so make sure you find 2000 ABBC1. So we're just going to do part A, which is find the area of region R. So this is graphed for you, which is super nice. You've got a function above, you've got a function below, and in order to find the area, we're going to do vertical cross sections. Vertical cross sections should be your first try. So they're going to look like this. And remember, these are little tiny skinny rectangles. And we're going to add them all up with a definite integral. So our height is going to be top minus bottom. So make sure you know what's on the top. Maybe we'll make that blue. And which one is on the bottom. So our height is going to be e to the negative x squared minus 1 minus cosine x. Don't forget the parentheses. That's a common error. Okay, so this is just going to be the integral of the height times the width from x1 to x2. This is our height. Our width is going to be dx. Remember, that's how wide these are. A little tiny bit in the horizontal direction. And we have to find the x1 and x2. Now that's non-obvious. A lot of people think that the intersection point is at x equals 1, but it isn't. There's no big fat dot, so you're probably not supposed to read it off the graph. So you're going to have to put this into your graphing calculator. To find the limits of your integrand, we're going to need to find where those curves intersect, and you're going to need to show your work. We're going to do it on the graphing calculator, but you still have to show what you're doing. So you're solving an equation, so you have to write that equation down. This is the equation that we're solving, but you're going to do it using the graphing calculator and intersect. So this is what it looks like on the calculator. You'll have your two functions in y1 and y2. You're going to want to graph it. Your original graph might look like this, but you definitely want to change your window so it looks like what's on the paper. So I'm going to change my graph so that my x's are going from maybe negative 0.5 to maybe 1.5. And with my y's, I know this is a cosine graph, so I'm going to try negative 1 to 2. Let's see what that looks like. So this looks more like what's on the paper. So remember, of course, if you want to find the intersection point, we're going to use the calc menu. We'll do intersect. So, and then we guess. And here's our intersection, x equals 0.94194. So you can write that down. And it turns out we're going to need to store this from the calculator. So what you do is, as soon as you've done this, if you go back to the home screen, second quit, if you hit x, that value is stored in x right now. What you need to do is store it someplace more permanent. The calculator changes x from time to time. So you just go to the store button, which is down here, store, and then we're going to put it someplace like alpha A. So alpha A. And now it'll be there even if x changes. Now that we found that the point of intersection, we can just write it down. X equals 0.9419. You don't have to show any of the work that you did. You don't have to explain. As long as you showed the equation, you can just put the solution. Now, to evaluate the definite integral, you have to write it out. So we're going from 0 to 0.9419. And my integrand is e to the negative x squared minus 1 minus cosine x dx. And we'll evaluate that using the graphing calculator. So when you want to do the integral, let's check what our functions are. So I'm going to need to be doing y1 minus y2. So I go back to the home screen, math menu. I'm going to do fn int, so I'll press 9. And I'm going to be going from 0 to a. So instead of typing that decimal in, I'm going to put in alpha a. And my height is going to be y1 minus y2. So I'll get that from the vars menu. yvars function y1 minus yvars y2. I'm using x as my independent variable. Hit enter. And this is my area between the two curves. So I write that on the paper, showing 3 decimal place accuracy. And once you learn that the answer is, you can just put it down, 0.590 or 0.591 if you round. And that's all you need to do.